Hi everyone, welcome to SDC India 2022. We are happy to talk once again at SDC event. Good morning, good afternoon, good evening, wherever you are. And today we will be talking about more on cloud native or Kubernetes native storage observability. We try to be focusing more on the storage observability and how we can build, and the first part we will focus more on what is observability and what is a kind of trend and where things are moving to. This part I think I have already talked in SDC EMEA also, the similar part. And the second part we will talk about the storage monitoring solution what we have, the open source storage monitoring solution what we have at Soda Foundation. We will also show the demo, and then our thought process towards how we can make that as Kubernetes native storage observability solution. That's the way we organized this session. Let me introduce with me Joseph Vazhappilly. Joseph.
Hey. Hi, I'm Joseph. I'm working in storage division of Huawei Technologies, and I'm contributing to Soda projects and especially Delphin projects. Yeah. Welcome to the conference.
Thanks, Joseph. Myself, Sanil. I'm part of the same team working on data management, and I work as a TOC co-chair in Soda Foundation, and trying to build this overall technology direction for Soda Foundation projects. Thanks, and hope you enjoy the session. Let's get started. So before we get into observability, what is the context in which we are talking about the container application deployment? So we have a lot of surveys. I mean, this is like 2020, 2021, 2020, 2021 kind of time frame, whatever research report happened. What it says is that the application container market growth is quite clear. You can see these numbers, and also container as a service, containers as a service, and hence storage. There are things like, I mean, everything is service today. So storage as a service, container as a service. Now we also have container storage as a service, right? Container storage as a service, CSTAS. And this is no more notional or trial basis, because most of the cases what the reports says is that the production level of container deployments are increasing quite significantly. We have seen industry reports, and we also did a survey, data and storage survey from Soda Foundation last year, and in that also it is prominent, very prominent, that most of the cases the Kubernetes based deployments are coming on the top deployment trend, and container storage is also used in real use cases, and the transition from VM to containers are happening kind of rapid in the last 5 years. So the summary is that the container deployments, application deployments are trending. If container deployments or application deployments are trending, means there should be enough support on container storage deployments, and more or less the distributed application and huge data processing is getting in AI, ML, big data, and so on and so forth. So container storage deployments are also growing. Primarily, if you see most of the container deployments, the COE, the container orchestration engine, is being Kubernetes as a predominant one. So this is a context in which we are talking about this storage observability. Now, many times we understand observability and monitoring little interchangeably, but there are some remarkable difference. So we'll see some kind of basic points about observability and monitoring. So monitoring, as you know, you watch the system, specific system information. Okay, you collect some specific predefined system information like bandwidth, that this kind of metrics information. You watch out, you observe and get. So basically what you do is that you are asking the system that you give me this information, and then based on that information you try to get some kind of anomaly, that this and all, like where you process this data and then identify the known unknowns, in fact, because most of the cases whatever is known, it could be coming in the future, but it can be known, maybe this can go up, down, things like that. So this is more or less very, I mean, a simple definition of monitoring. Now in the case of observability, it's majorly based on the outputs from the system. So what observability tries to do is that based on the output of the system, it tries to derive the behavior of the system completely. So an ideal definition of observability means if you can completely define the system behavior from the output, only based on the output, then that's a pure kind of deployment of observability. And basically even the current state can be estimated using the information from the outputs. Of course, the insights to the system behavior is part and parcel of it. So we can understand in such a way that the monitoring is inherent part of observability. The key point in observability is that you will be able to get unknown unknowns, in the sense till now you don't know what can happen to the system. That kind of information can be popped out based on the observability analysis. I mean, that's a key difference. One is that you get some specific information, but in observability you derive the behavior from the output. So most of the cases you can get something really unknown so far. So little more details on observability. As you see, metrics, logs and tracing are major part of effective observability. So it's kind of, I mean, that way it's already kind of monitoring, right? And it depends on how well the internal states are inferred from the external output. So whatever outputs are coming and the internal states, how well it can be inferred. Sorry. And like we discussed, effective observability solutions take all possible system output for deeper analysis, not just one or two or some specific information, all possible outputs which will be part of the analysis of observability. So I just try to put some, I mean, illustration that consider metrics in monitoring. So monitor some metrics, and once it crosses threshold, give alerts and things like that, or you can even do AI/ML, anomaly detection, pattern, all these things can be done. In the same case, observability means high cardinality metrics, in the sense the set of metrics or set of numbers which are part of this will be quite huge, with huge system information to infer deeper insights of the system. So not just a particular set of anomaly in these values. That is not the way observability works. And like already we discussed that the system behavior, how well we can understand the system behavior. So it's just a continuation of what we discussed, that all possible states and patterns of the system, faster identification of the issue and optimization, and suitable dynamic and complex systems. This is more suitable for dynamic and complex systems, wherein the behavior can be, I mean, very different at a different point in time for different inputs and things like that. So usually in monitoring, you pre-configure info you need, but in cloud native or distributed complex container application deployments, you are not sure what kind of problems that can arise, or what kind of the configurations or the scaling. For example, the resource scaling itself, it's quite dynamic in these kind of distributed systems. So in such systems, the monitoring can give you limited health information and actions, whereas observability can help you to get even complex system behavioral issues in advance and take proper actions to fix it. And why observability important? We have already discussed some points. It's hard to anticipate the type of issues. And if you see, a new trend is AIOps. So DevOps is transforming into AIOps. So end-to-end AIOps, you need observability systems. And new system behavior or the issues can be unveiled with the observability capability. Hence, the service quality and customer experience will be much better. And even the efficiency of the SRE teams will be much better to make your system secure and resilient. And of course, it will be more cost effective. Yeah, so here there are some challenges in implementing the observability because it doesn't come easy. The monitoring itself is hard for us to implement in various cases, and mapping the importance and weightage of each of the performance metrics in the behavior and stuff like that. So one point is that the source silos, because the source of the information is huge, quite huge, because when you try to see the system behavior as a whole, going beyond some set of specific metrics, it's going to be the tough to get. So the source of truth is very hard in these cases. And observable system design, because the system should be designed for observability. So most of the legacy systems, it will be very hard for us to build up your or good observability solution for those kind of systems. So most of the new systems are trying to consider how well it can be, the system behavior can be observed based on the internal states and things like that. And there are too many tools, because once any technology for that matter, if it is prominent and going in that direction, there will be so many private open source tools and solutions will be available. We'll see some of those in the subsequent slides. And huge volume of data and unstructured data, because it's very hard for getting the structured data and processing of this unstructured data to get the valuable information from that. It's very hard. So basically the goal is a single source of truth, consolidation, unified, and right AML module automation, basically. Now we'll come to see that how the container storage observability is shaping up. Quickly we will see what's happening just to scare you, and then we will move on to what we have. So if you see cloud native project landscape as a whole, it is really growing, because most of the multi-cloud or distributed systems are moving towards more on cloud native. So the landscape of cloud native project has been growing, hence even the observability and analysis. So there are different kind. If you see the cloud native, this I have taken from CNCF, only CNCF. There are other projects outside CNCF. This is only CNCF landscape. So from that, there are different categories for observability and analysis. One is monitoring part. So these are the number of monitoring related projects. It's not exactly the monitoring, but related to monitoring, like Prometheus. Prometheus, it's not just monitoring, but it does support some kind of processing, analysis, and kind of stuff. And then you can see Grafana. Grafana is just visualization, in fact. Visualization and a little more, but primarily on visualization. Nagios, Thanos, OpenMetrics. There are so many open source projects, and also there are commercial products available. On this include both open source and proprietary, based on open source or proprietary. This is for monitoring. And then logging and tracing. There are set of projects specifically focusing on logging and tracing. There are so many number of projects which is, so all these in CNCF landscape, when you build a solution, you pick and choose. You can pick monitoring, logging, tracing, which are suitable for your solutions, and then say, for example, open metrics for monitoring and open tracing for the tracing purpose and things like that. Fluently you can use it for logging. and then you can build your solutions. This chaos engineering is something like an intrusion, error injection and identifying the issues faster, better. So this is a new area which is called chaos engineering. There are new projects coming up like Litmus, which is very prominent project. And then continuous optimization for observability. So see, what I want to tell you is that there are large number of projects getting into this particular area, observability and analysis area itself, both open source and proprietary. This indicates also the trend what we have seen in the beginning of our talk. So this tells us that observability is critical and there are opportunities in this area. Another point I just wanted to bring is that the Csi volume monitoring. So as you know, in Kubernetes or even container deployments, the storage interface is through Csi, container storage interface. And in that, if you see the monitoring features, even just the monitoring features are limited for storage, even for pool level or the storage level, deeper information is not available. So it gives PVZs related information or the port related information and a PV metrics. What are the other ways we can get? Other ways are like cloud vendors provide some specific tools, maybe Azure, Amazon CloudWatch and AWS CloudTrail log monitoring. All these tools will provide you some kind of monitoring and observability capability. Other than that, the storage vendor solutions. So for example, if you buy any storage for that matter, the vendor will give you a management system which also has the monitoring and to some extent observability. Then there are researches happening for smarter observability solutions. You can actually search. There are a lot of papers these days. So all these means many tools, solutions and research happening. So if you want to have comprehensive container storage observability, there are many challenges. It is distributed and dynamic, application aware, silos, too many tools, limited observability support from CSI, which is the native storage interface for Kubernetes. And we need to support something like a heterogeneous hybrid kind of environment, different kind of storages, different kind of environment like edge, on-premise and cloud. Then we need to have integrated intelligence to it. And there are a lot of legacy storages which were not designed for observable systems. And there are different kind of system information or behavior we need to consider. So there are a huge number of challenges. So challenges means opportunities. It's a critical trend and the research is happening. There are projects coming up. So that means though you have challenges, there is a huge demand for the solution for observability solutions for the deployments. So this is where we stand today. And now based on these trends, what are we doing at building Kubernetes native observability at Soda Foundation? So we have some solution. We are thinking something where we thought that it is the right time to discuss with community and see that what are your inputs. So Joseph will take us through what we have and what are the key features which we have. Joseph?
Yep. Thank you, Sanil. Thank you, Sanil, for the introduction. So here in Soda Foundation, we have some projects in cloud native, and I'm introducing Delphin project for the storage solution. Sanil, next slide, please. So Soda Delphin is a storage monitoring project for heterogeneous storages. Here, I will introduce a Delphin project and some of the demos and how we can integrate these observability features into Delphin, and some discussion on challenges for these tasks. So first, I'll introduce the Delphin. From user's perspective, Delphin provides a heterogeneous storage monitoring. It means multiple storage vendors can we can observe and use Soda's Delphin for monitoring for the multiple storage vendors. It supports resource monitoring. Resource monitoring means it provides details of storage, pool, volume, port, networks and controllers, and NAS file system, NAS share, quota, and tree, and mapping of these views, mapping of usage views and topology relations. For performance metrics, it provides bandwidth, throughput, IOPS, response time, capacity. These kind of metrics are collected periodically and exposed to the users. Delphin can handle alert management. It means we can receive SNMP trap and parse it and expose these traps to the users. As well as it can directly connect with the vendor software and expose the alert details to the users. It supports a driver manager, which is a pluggable in architecture. We can easily integrate a new storage vendor storages to this Delphin driver manager so that it can be supported through Delphin. Multiple vendor platforms also can be supported. So some vendors will provide their own solutions. These can be supported through centralized manager support of Delphin. And it got plugin managers for exposing our output from Delphin. Means our collected resource details and performance monitoring metrics can be exposed through Prometheus, Grafana, Kafka, these kind of clients, and it can be extended through a plugin type of architecture. One advantage of this is the details collected from Delphin can be used for further processing, AI and ML kind of analysis, and for value addition for the clients. So these are the user-specific features supported in Delphin. Now we'll see what are the internal architectures of Delphin. Yeah. So right-hand side, we can see that the internal components of Delphin. At the rightmost side, we expose outputs to the users through this Prometheus and Kafka. At the bottom, we have storage arrays. Multiple storage vendors are supported through pluggable drivers. I'll go through each modules. We have a unified REST API. So any user can use REST APIs to get all the features of Delphi. Output can be visualized through Kafka or other third-party Kafka, Prometheus, Grafana, or other third-party exporters. The important module is a resource manager. Resource manager is responsible for adding a new storage for monitoring, and it syncs the storage for resource collection, and other tasks are started through resource manager. Next module is a task manager. Task manager is a periodic, it runs periodically for collecting performance metrics and exporting it through exporters. We have an alert manager. Alert manager module will asynchronously receive SNMP trap from a storage. It also collects details of alerts from the backend storage and expose these through exporters. We have a driver manager here. Driver manager supports pluggable drivers. So any new driver can be written in a pluggable way. So easily integrate, it can be, any new driver can be easily integrated into Delphin through writing some pluggable drivers. It supports REST, SSH, CLI, and SMIS interfaces to the third-party storages. We have this exporter interface. This is well-defined interface through which users can utilize outputs from Delphin for further analysis or data enrichment. This is the overall architecture of Delphin. Now we'll see some of the demos. for Delphin. Yeah. Next one. Delphin summary is Delphin project is Python based and framework is similar to it is based on OpenStack. It provides an agentless and less intrusive deployment. We don't need to install any third-party storages into vendors network users storage network. Delphin sits in control plane. It will not interfere with any of the storage and management, storage and data path. Delphin is fully open source, vendor neutral, and supports secure deployments. It provides pluggable drivers for dynamic storage and addition. Yeah, these are the interfaces. REST, CLI, SSH, and SMIS are supported. Delphin supports export of Delphin matrices and visualization through Grafana and custom dashboard. Using this exporter framework, we can add some AI ML integrations to further enrich the data and make it more useful. It supports performance scaling. Multiple processes can be dynamically created so that a large number of storages can be managed through Delphin. Yeah, next slide, Sanil. Yeah, we'll see some of these demos using Soda dashboard and some of the deployments. We can start with demo 1. Yeah, in this demo, we are seeing Soda defined dashboard, and we have integrated Delphin to this dashboard. Currently, we are registering a new storage to the dashboard so that Delphin can manage this storage. This is a demo storage. We have a simulated storage for testing purpose. So interface supported is REST and SSH here. It shows that device is registered successfully. We can see the summary of resources here, and details of resources can be visible by clicking on the links. We can request sync so that it will collect latest information from the backend and display the latest collected information. Each storage displayed here is individual vendor storages. For test purpose, we are using some simulated storages. We can configure SNMP trap for the alert source so that these SNMP traps can be managed through Delphin. These are the capacity details collected by the Delphin. This shows detailed summary of the capacity details. We will see performance monitoring next. Currently, it is not collected much details. So next demo, we will see the performance collection and metrics details. For each storage, we can start metrics collection. Currently, it is not collected, but once we configure interval and configure performance metrics collection, it will start collecting the metrics. It will be updating this dashboard. This dashboard is integrated with Prometheus Grafana. So collected metrics will be exposed to Prometheus, and that will be displayed through Grafana. So configuration for metrics collection can be done in several places in this dashboard. Currently, it started collecting the matrices. It uses similar interface like Grafana. These are the random data generated by the simulator for each matrices. We can select individual storages or see all the storages together. These are the different matrices collected. So this is the interface for the alerting. We can see details of the alerts from here. This is Prometheus Alert Manager. So info provides details regarding the alert generated and the storage device that generated the alert. Yes, that's the features demo of Delphin. Now we'll see how one of the example deployment of Delphin in Kubernetes. We have some repository. A link is provided in this presentation. So we have deployed Delphin in a kind Kubernetes environment. We can see that demo here. This is the kind deployment cluster, kind cluster details here. We have exposed Delphin port outside for APIs. These are the ports deployed in kind cluster for Delphin. These are Delphin APIs. We can register a storage and see the storage details. It's a sample storage. We have successfully registered the storage here. We are getting some of the storages registered, already registered. Yeah, the detailed steps for doing this demo is available in the links provided. These are the details of Delphin deployment in Delphin Kubernetes deployment. Sanil, maybe you can take over.
Yeah, thanks, Joseph. You are able to hear me, right?
Yes.
Okay. So Joseph was explaining on the Delphin features and what we have and what we have tried in the uh, Kubernetes. So from that motivation, we thought that we should start thinking about more Kubernetes native observability. So this is some kind of a thought process right now. What we have on the solution, what could be a good starting point towards that solution. So as you know, on the you can see the Kubernetes clusters, and CSI is by default connecting to all these storages. I mean, different kind of storage vendors. And what we are thinking is that we can have Delphin natively deployed in Kubernetes. Then Delphin by default, like Joseph mentioned, it support Prometheus or Grafana, Kafka, all these exporters or any custom third-party exporters available. And then the challenge will be the CSI vendor driver will have certain features, CSI spec will have some specified certain monitoring features, may not be more features. So either we need to have some kind of an extension to the CSI capabilities, some sidecars to help us to fetch more data from the storage. And also we may need some kind of facility to get the data from at the storage level, maybe the pool level and things like that. If it is not supported in CSI, we need to find some mechanism to get that data. And Joseph, right now, whatever we have tried is the APIs is directly called to Delphin. It is not going through Kubernetes, right?
Correct. Yes.
Okay.
So
yeah, go ahead.
Yeah, for making more cloud native, we need to add changes to the API layer. Currently, it is not supported.
Right. So maybe one option could be like we make a Delphin set of APIs Kubernetes native, so we can use maybe something like an operator, and
Correct,
different
yes.
features can be something like a different operators, maybe for alert performance, or maybe the resource management. We can have different set of operators, and then we can, so part of that we can have controller and the CRDs to define new API specific to the monitoring or the observability part.
Yes.
So what we are thinking is this way, that because we have a confidence that Delphin can run in Kubernetes, and now the step would be something like dismantle this guy into properly structure into different operators and provide those APIs in Kubernetes. And the drivers part, because right now Delphin support Delphin specific driver, correct, Joseph?
Correct, yes.
Yeah, so we need to find a middle path to exploit a maximum out of CSI, and then maybe only Delta should be available in the the other driver part, even in the Kubernetes side. So these are some of the thoughts for our going forward towards Kubernetes native observability building. This could be a very good starting point because we have a working project and we have some thought process to how we can make this working in a Kubernetes native way. Now, these are some of the use cases like heterogeneous container storage observability, because if you see there are a lot of different vendors. Even in Soda, we have a provision to support multiple storage vendors in CSI. Soda CSI support that way. We have the sidecars to support heterogeneous storage at the same time. Monitoring or the observability part, with that kind of systems where you have different storages deployed for your application deployment can also be a good use case. And then unified visualization, storage analysis, and apply AML and predictive analysis and preventive action. So end-to-end, probably end-to-end AIOps and hybrid observability, even for cloud monitoring or edge, we can actually extend this solution. And like we discussed, we are trying to make it more cloud native, microservice, and CSI more. We don't want to go away from CSI, but best use of CSI, and wherever Delta is there, we can add, and we can also work with CSI working group and see that whatever we are doing delta, whether it can be merged into CSI, so that it will be more standardized. And of course, support of seamless support for external interfaces like clients like Prometheus, Kafka, or any third-party clients is easy to integrate. And the capability also can be extended, because the operator model will help you to extend the capabilities, or even new APIs and new capabilities. It will be very easy for us to do. Again, there are complex scenarios which we can consider: real-time performance federation. The cluster, even the SIG federation also is going on, working on the Kubernetes federation support. So that area also is a bit complex, and cloud edge and distributed observability and like marketplace for tools. These are some thought process which we have for something like an advanced solution for end-to-end observability framework. Now, having said that, we are just started thinking about it, and we just started the Delphin migration to Kubernetes, right? I think that's the first step we have taken, right, Joseph?
Right. Yes.
So
yes.
now we also discuss this in community, and some of the members interested to work towards this. So we are trying to form a team in the community, completely in open source space under Soda Foundation, under Delphin project right now, to explore this, whether this design is fine and this is the direction okay, and then work together to build this kind of maybe an observability solution, which is there is a good potential for the solution out there based on all analysis what we have seen today. So this is the right time to collaborate together. Now is the right time. So this is completely open source and community driven, and we also have some kind of collaboration with CNCF. We also observe what's happening in the work group so that we can collaboratively develop. We can also give inputs to them. We can take inputs from them. So what you need to do, if you are interested to join at whatever level of skills you have, it doesn't matter. If you just have interest in this topic and want to contribute or work together with us, you just need to join us, and that is very, very simple. You can just join the Soda Slack, sodafoundation.io/Slack. Just join, and then we have a container observability channel like Soda CDM. You can just come there. You just say, I want to contribute. That's all you need to do. So rest, some of us will take care of it. Even in the general channel, you can do the same. So this is the easiest way to get in touch with us. Joseph, you want to add anything? I think you are already communicating with some of the members, right?
Yes. Yeah, we have this Slack channel. Mainly, we use Slack channel for connecting with developers.
Okay. And yeah, before we closing, that's what we have today for the observability part. Before we close, like I mentioned, we had the Soda Data and Storage Survey 2021, and now we have come up with Soda Data and Storage Trends 2022 with some specific areas of questions, multi-cloud, container, and things like that. It takes around 10 minutes to fill the survey. So I know most of the people in SDC, I think they will be one or the other way connected to storage and data. So please take, whenever you get time, a break, just go to sodafoundation.io. In the landing page itself, we have the banner. You can click there. Please give your valuable inputs, because collectively all these inputs will help us to understand what are the specific directions, what's happening in the technology for data and storage. And collectively we can take some steps in the open source towards that trend, meeting that demand from the users. So please do fill the survey, and that's all from our side today for this session. And we have put all the links about Soda source code and the website, so you can anytime contact us. And we also did some kind of references, whatever useful links related to observability and other stuff we just added at the end of the slide, which may be very useful. Joseph, you want to add anything?
Yes, that's it.
Okay. Yeah, thank you so much for listening to us. Enjoy the rest of the conference and have a nice day. Thank you so much.
Thank you.